Okay, we're looking at chapter 6.4, common denominators and equivalent fractions. A couple of things we have to do. There's several ways to work at it. We have to understand what common denominator is first, I guess. Common denominator, your book says, is a common multiple, or fractions that have the same denominator. You can use common multiples to do that. So you can use multiples. Oh, multiples. There we go. Which, like the multiples of the number 6 are 0, 6, 12, 18, and so on. You just keep on going. And it's kind of like your times tables, your multiples, multiplication facts. Common denominators are denominators, the bottom part of the fraction, that are equal. And we're looking at a couple of things. We're looking at 1/3 plus 1/4. We can't add these because the denomination, or the denominator, is different, 3 and 4. Remember the example we use often is like adding nickels and dimes. You can't add nickels and dimes. 1 nickel plus 1 dime doesn't equal 2 nickels, and it doesn't equal 2 dimes. It equals something different. And you have to break it apart into pieces that match. If you took your dime and you split it into 2 nickels, then you'd have 1 nickel plus 2 nickels equals 3 nickels, and that works just fine. So this is like 1/3 plus 1/4. And they want you to think about a picture first. So we're going to start with a picture of a third. See if I can draw some decent circles. They're not going to be perfect. That one especially. Alright. Okay, so we have 2 circles, and we're going to make this one into thirds. And we're going to make this one into fourths. Okay, and we're talking about 1/3. I wonder if I could use my fill-in bar. I'm going to just go ahead and cover up that fractions. We don't need that anymore. I'm going to try it. And we're going to use something light like yellow. There we go. Alright, 1/3 plus 1/4. That actually worked better than I expected it to. Oh, wait, that doesn't work. I want a better color. Yeah. Okay, so now what we do is we're going to take, we need a common, this is a different size than this. The 1/3 is different size than 1/4. So they want you to imagine that you cut each of these pieces into fourths and each of these pieces into thirds. Now if we do that, cut these pieces into fourths, so I'm going to start by just cutting this third in half and then cutting each half in half again. This gives us 4 slices. 1, 2, 3, 4. And if I did it all the way around, cut this one into fourths, cut this one into fourths. Now it's not perfect, I'm trying to hurry, but you can count the pieces. There's 4 in each original third. So there's 4, 5, 6, 7, 8, 9, 10, 11, 12. There's 12 pieces altogether. And if we cut this fourths into thirds, we're going to do the same thing, but instead of cutting each piece in half and then half again, we're going to cut each piece into 3 pieces. And we cut this piece. Okay, so there's like 1, 2, 3, 1, 2, 3. You can see that I'm just going to go 1, 2, 3 in this third, and I'm going to go 1, 2, 3, and 1, 2, 3 in this third. And again, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Again, I have 12 slices. If we're talking about pizza. 1/3 is the yellow slices, and 1/4 is these yellow slices. And you can see that I've just changed it into, it's the same thing as 4/12. 1/3 lines up with 4/12, and 1/4 is 3/12. And we can now add it and get 7/12. Now if I rewrite it so that it's vertical, 1/3 third plus 1/4, and 1/3 comes over here and becomes 4/12 right here, 4/12, and 1/4 comes over here and becomes 3/12, and now when I add it I get 7/12, and this is my answer. This was my answer. If I add these pieces up, that's what happens. It works out pretty well. So 1/3 plus 1/4, 1/3 plus 1/4 is 7/12. Ooh, let's do a better job than that. 7/12. And you can see from the shaded areas that's what you get. Now, this is a picture, and you can't draw a picture every time, so you have to understand that you're looking for a common denominator. Another way to do it is to list the multiples. We're going to do the same problem again because you have to understand what's happening. We're going to just keep going. Let's use thirds and fourths. We have the multiples of 3, 0, 3. We usually don't even use 0, but it is one. 6, 9. Oh, look at that. I'm getting ahead of myself. I know too much. 12 and 15. That's the multiples of 3. The multiples of 4 are 0, 4, 8, 12, 16. And if I circle the ones that are in common, there's a 12 and there's a 12. So 3 and 12, or 3 and 4, both go into 12. And if I want to know how many times 4 goes into 12, 4 goes into 12 times 3. And 3 goes into 12 times 4. So 3 times 4 is 12. 4 times 3 is 12. So this is kind of another way to figure it out. Every time you start here with 1/4. Let me just kind of redo this real quick. 1/4 is the same as 2/8 is the same as 3/12. I'm just counting. 1/4, and then if I cut that in half, I'm going to get 2, and then if I cut the 8 into 12, I'm going to get 3. 3 slices, and we showed that on our other page. 1/2 equals 2/8 equals 3/12. And if I do it for thirds, 1/3. Thirds is first equals 2/6 equals 3/9 equals 4/12. So I've got 4/12 and 3/12, and I can add those up. 3/12 plus 4/12 is equal to 7/12. And I already knew that was what I was going to get from the last problem. Now if we wanted to do it another way, I could write it 1/3, and I could just think, well, times 4/4 equals 4/12. This is what we started with. We multiply it by a factor of 1. I always want everybody to notice this because I think it's really cool. That when you multiply by 1, you get the same thing. And all we did was multiply by 1. So 4/12 is actually equal to 1/3. We just multiplied by 1. 1/4 times 3/3 is equal to 3/12. So 1 times 3 is 3. 4 times 3 is 12. Now this is the hard part. We're teaching you how to add fractions, and I'm showing you that you sometimes have to multiply in order to add, and that could be a little bit frustrating for you. Bear with me. We just kind of have to work with this until it starts to make sense, and we'll do it a number of times and it'll just keep happening. We'll just keep working with it until it starts to work out. Again, 4/12 plus 3/12 is 7/12, and this is a good way to do your math right here, just using multiplication. And we're going to just do this over and over again. Let's see. Let me pause this real quick, and I want to check something in the book. Okay, let's switch. We're going to finally do something different. 3/4 plus 1/6. Now, one of the reasons we use that counting by multiples, the common multiples, is the same as the common denominator. And I'm just going to use 4 and 6. And 4, 8, 12. I'm counting by 4s. And if I count by 6s, 6, 12. And right away I can stop because ding, 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 those two match. So I just have to change 1/6 into a certain number of twelfths. And I need to change my fourths into the same number of twelfths. Okay? And this time we can just notice that 6 times 2 is 12, so 1 times 2 is 2. So 1/6 is the same as 2/12. If I cut that little 1/6 in half, cut it in half, I now have two pieces, and they're half as big. That means they have to be twelfths. Okay, we don't really need that, but sometimes I want you to think about those pictures. Let's switch to green. How do I go from 4 to 12? I multiply by 3, and if I multiply by 3 up here, 3 times 3 is 9. I want to multiply by the same number. This is multiplying by 1 like I showed you. So it's 9/12 plus 2/12. And then if we put our fraction bar down here, our answer bar, 9 plus 2 is 11/12. And that's our answer. Okay? Now, let me really quick show you how the book does it. It's basically the same thing. They have 3/4. There we go. 3/4 plus 1/6 again, and they rewrite it just like we did as twelfths, and they rewrite this one as twelfths. But instead of just filling it in, they put a little question mark right here. They put a little question mark. What? How many twelfths is it? We know that 4 and 6 go into 12. We got to figure out how many times. All right, and so then they say, well, the bottom is the same as 4 times 3. See how 4 is equal to 12 is equal to 4 times 3. 4 is not equal to 12, but if I were to multiply, if I knew what number fit here, it would be the same. Okay, and since I'm multiplying 4 times 3, I've got it here. They multiply 3 times 3. Now I use the little arrows, and I put the multiplication right here and the little arrow. That's what I did on the last page, and I actually like that better, but the book wants you to see it this way. And then they put their answer in 9/12. Put it in like that. So this is the question mark. This is the one you don't know. But if this were 9/12, it would be true. You have to make it true all the time. So this is 6 times 2, because that's how you get from 6 to 12. And then 1 times 2. And notice again we have 2 halves and 3/3. So we're really multiplying by 1. 3/3 is 1, and 2 halves is 1. But it comes out to 2, 1 times 2, over 12, 6 times 2. And again, 9 plus 2 is 11/12. And I know that's kind of fast. 9 plus 2, 9/12 plus 2/12 is 11/12. Okay, so that's what we're doing. You've seen it like 5 ways, and I know sometimes seeing it in multiple ways is confusing. But this fraction concept is super important, and they are going to ask you some of the time just to find the least common denominator. That's called the LCM. The LCD. The least common denominator is the smallest one. Remember how we used 1/3 plus 1/4, and we came up with twelfths? Some of you might have noticed that 3 times 4 was 12. But then we did another problem where it was 3/4 plus 1/6. And if we had used the same idea, 3 times 4 is 12, we would have said 4 times 6 is 24. But we didn't do that. We didn't go to 24, we only went to 12, because both 4 and 6 go into 12. So even though we could have gone to 24, we just left it alone, and we went to 12, because 4 times 3 is 12, and 6 times 2 is 12. and so on. So we get to 12 by multiplying 6 times 2 and 4 times 3. And we were able to do that fraction. So the least common denominator is kind of what we're looking for part of the time. They might give us something like 11 twelfths and 5 eighths. And they don't actually want us to add them or do anything. They just want us to find the smallest number that both 12 and 8 go into. And again, it's okay to just count by twelfths. 12, 24, 36, and then count by eighths. 8, 16, 24, 32, and then say, oh wait, 24 is the smallest number that both 12 and 8 go into. Now if we'd multiply them, 8 times 12 is like 96. 96 works, but it's a really big number. It's nice to stop at 28, 24. I guess we could have also stopped at, because it would happen again at 48. It would happen again at 72, and then it happens again at 96. So we keep running into numbers that work, and with a whole bunch of numbers in between that don't work. We're looking for the least. LCD is the least common denominator, and often they call it the LCD. It doesn't look like they're calling it this and that in this book, but you do need to remember that LCD is equal to least or smallest common. That's the ones that they have in common, the ones that are in both 24, 48, 72, 96 denominator. Okay, that's that. That's all you have to do. Write equivalent fractions using the least common denominator. So it looks like we're not even adding them yet. We're not even really adding them today. We're just trying to find them, like 7 tenths and 3 eighths. What do both 10 and 8 go into? Now sometimes you can just look at the number and you can write, you can figure it out. What do both 8 and 10 go into? Well, 10, 20, 30, 40, well, they both go into 40. And you know that 10 times 4 is 40. Let me do that in a different color just so that we can maybe possibly remember it better. Blue. 10 times 4 is 40, so 7 times 4 is 28, and these are equivalent. 8 times 5 is 40, so 3 times 5 is 15. 1540 is, so 7 tenths times 4 fourths equals 28 fortieths. And that's this one. This one is 3 eighths times 5 fifths equals 15 fortieths. And that's that one. So the two equivalent fractions are 28 fortieths and 15 fortieths. We don't have to add them or anything. They're just trying to teach you how to find the smallest number that both denominators go into. And then you have some story problems to do that go along with it. All right, thanks for listening.